Okay, so now let's continue looking at our introduction to economics by introducing rational choice theory and first the notion of preferences. So economics, as I've been saying, is all about modeling the decisions that users, consumers, individuals, firms make when you're given multiple choices and when interacting with others. And rational choice theory is the fundamental model for decision making that is used in economics. It was first developed in part by John von Neumann, and game theory, which we'll talk about later on the course, is an extension of rational choice theory to model strategic interactions. But first, we're just going to talk about what rational choice theory entails. So, I think there's an intuitive definition we could give for rationality, which would be that a rational individual acts in his or her perceived best interest. And rationality is what motivates the focus on incentives, looking at individual actors following their own interests. Now, can you think of scenarios when this definition doesn't hold in practice? Can you think of cases in which agents would decide not to be rational? We'll leave that for a discussion. But if we want to go from this sort of intuitive definition to one where we can actually build models, and preferably one where we can do some mathematical modeling, we need rational choice theory. And what it does is it states the available outcomes, articulates preferences among outcomes, and does so in a consistent way that is deemed rational. So here we go. We have an agent who's faced with a range of possible outcomes, say outcome 1, outcome 2, and they're within the set of all possible outcomes. We'll call that O. And we'll introduce some notation here. You could say that O1 strictly prefers to, is preferred to O2, so you use that little curly greater than or equal sign. Then you add a little bar underneath if you want to say O1 is weakly prefers O1 to O2. And O1 is, tilde O2 means the agent is indifferent between these two. Okay. Now you can think of an outcome as a single variable, but you could also treat these as a vector, where you have a tuple of different properties, and you're considering the different combinations of those constituent parts. So rational choice theory is predicated on a few fundamental axioms that essentially assume consistency in how outcomes are preferred. And the first axiom is completeness. So saying for every pair of outcomes you give, O1 and O2, one of these three things must hold. You either prefer outcome 1 to outcome 2, you are indifferent between the two, or you prefer outcome 2 to outcome 1. And if you accept that for any arbitrary outcomes you will prefer exactly one of those three, then that means you can always compare preferences, or always compare outcomes, and then subsequently construct preferences. Now, the second axiom is transitivity. So let's say you have three outcomes, O1 through O3. If you prefer outcome 1 to outcome 2 and outcome 2 to outcome 3, then you also prefer outcome 1 to outcome 3. So this is just requiring consistency across multiple decision preferences. So that's it. Those are the three fundamental axioms, and then we can start building our model of rationality from there. So let's look at the trade-off between confidentiality and availability using cryptography. So let's say Alice prefers to have a confidentiality in her communications with Bob, but she also wants to be sure that she can actually communicate to him. And so there's a natural trade-off there, because if your cryptography mechanisms don't work or the other side can't use it, that makes them unavailable. So we can sort of simplify this to a world in which we have four outcomes, C+, C-, A+, and A-. And C++ means you have a mechanism that achieves high confidentiality, C- is low confidentiality, and similarly for availability. And we can start to articulate our preferences once we've set out those outcomes. Clearly, we prefer high confidentiality to low confidentiality, and high availability to low availability. And you can put these together in a tuple by saying that if you have both high confidentiality and availability. You prefer that to both low confidentiality and low availability. So, but what about the in-between case where you have high availability and low confidentiality? Well, different users may have different preferences there, but another outcome could be that you're indifferent between the two. Let's say you're indifferent between having high confidentiality and low availability, and low confidentiality and high availability. We can think about these indifference here, not just as discrete comparisons, but sort of on a continuum, and that's what indifference curves do. So let's say we have this simplified graph here, where you have levels of confidentiality compared to levels of availability. So let's say it goes from 0 to 100 in each case. You know that you would say that maybe low availability, high confidentiality would appear as this point on the graph, and high availability, low confidentiality would be on the that point in the graph. And so let's say you're indifferent between those two. Okay, well, you can sort of imagine what if you just slightly decrease availability and increase confidentiality? There must be some sort of continuum of points at which you are indifferent between the arrangement of those two outcomes. So, like in the middle, there's A0 and C0, which is, and if you sort of fill all the points in between, you can end up with a line called an indifference curve. And what this means is that any point along these lines. Along this line, you are indifferent between the value for each of these. So between the arrangement of in this case, the two variables of availability and confidentiality levels. Now, what happens if you have another indifference curve that's sort of up and to the right, like we have here? Well, what you would say here is, because you're going up and to the right, meaning you're getting higher levels of availability and confidentiality, that is a curve that you must prefer to the other case. Okay, so if you can somehow jump from the lower indifference curve to the upper one, you've actually improved your outcome. You prefer any arrangement on that upper indifference curve to any arrangement on the lower one. All right, that should wrap it up for this video.